On this video, we like to talk about sum and difference identities. So let's first begin with this example. Sine of quantity 30 plus 45. Now let me ask you a question. Is this same thing as sine of 30 plus sine of 45? What do you think? Well, there's one way to check. So that is, what's 30 plus 45? The sine of 75 degrees. And what's sine of 30? That's 1/2. What's sine of 45? Radical 2/2. So on the right side, you get 1 plus radical 2/2. Now the left side, what is sine of 75? Well, we need our, at this point you need a calculator. So when you use your calculator, you'll notice that sine of 75 is 0.96592, and it goes on. And on the right side, quantity 1 plus radical 2/2 is actually 1.2071, and goes on. So you can see these two are not equal to each other. So you got to be careful when you solve this type of problems. So what can we do? How can we solve sine of quantity 30 plus 45? So we have formulas for sum and difference identities. For example, if you want to find cosine of quantity alpha plus beta, that will be equal to cosine of alpha, cosine of beta minus sine alpha, sine beta. And if you want to find cosine of quantity alpha minus beta, that will be equal to cosine of alpha, cosine of beta plus sine alpha, sine beta, and so forth. So I'm not going to go into detail of how we got these formulas. I'm just going to focus on how we could apply these formulas when we solve sum and difference identities. Let's take a look at this example, cosine of 15 degrees. Now, you know that 15 degrees is not a nice angle. What are the nice angles? You know that 0, 30, 45, 60, 90. These are nice angles because you could easily find cosine of 0, cosine of 30, and so forth. So somehow we have to rewrite 15 using these nice angles. So how can we write it? Well, cosine of quantity, how about 45 minus 30? Okay? Now, some of you might say, can we use cosine of 60 minus 45? Sure, as long as you use two nice angles, it doesn't matter which one you use because you'll end up getting the same answer. So now let's take a look at this. We know that 45 will be alpha here and 30 will be beta. What was the formula for cosine of quantity alpha minus beta? Well, that was cosine of alpha, cosine of beta, plus sine alpha and sine beta. Okay? Now all we're going to do is substitute. So 45 for alpha and 30 for beta. So it's going to be cosine of 45, cosine of 30, plus sine of 45, sine of 30. Now let's simplify this. What's cosine of 45? That's radical 2/2. What's cosine of 30? That's radical 3/2 plus sine of 45, radical 2/2, sine of 30, that's 1/2. So you end up getting radical 2 times radical 3 will be radical 6 over 4 plus radical 2 times 1 is radical 2 over 4. So you end up getting radical 6 plus radical 2 all over 4. And you might want to use your calculator to check if cosine of 15 is this expression right here when you change that to decimals. Let's take a look at this example. You have sine of quantity 5 pi over 12. Well, it's always kind of easier to work with degree. So if you change radian 5 pi over 12 to degree, well, pi is same thing as 180. So 180 divided by 12 is going to be 15. 15 times 5 will be 75. So 5 pi over 12 in radian is equal to 75 degrees. So I like to change that to sine of 75 degrees. Now again, 75 is not a nice angle. So how can we write it? Well, we can write it as sine of 30 plus 45. Now again, please do not say this is the same thing as sine 30 plus sine 45. This is not equal to each other, and that's the common mistake that students make. So do not make this type of mistakes. So what do we have to do now? Well, we know that 30 is alpha and 45 is going to be beta. So we have to look at sine of quantity alpha plus beta. And we know that that's the same thing as sine of alpha cosine of beta plus cosine of alpha and sine of beta. Okay? And now all we have to do is just use substitution. So it's going to be sine of 30 cosine of 45 plus cosine of 30 sine of 45. And let's simplify this. Sine of 30 is 1/2. Cosine of 45, radical 2 over 2. Cosine of 30 is radical 3 over 2. And sine of 45 is radical 2 over 2. So when you simplify, you're going to get radical 2 over 4 plus radical 6 over 4. So you end up getting radical 2 plus radical 6 all over 4, and that will be your answer. Again, you might want to use your calculator to see if sine of 5 pi over 2 is equal to this expression when you change it to decimals. All right, let's take a look at this example. It says, find exact value of cosine of 7 pi over 8, cosine of 5 pi over 24, plus sine of 7 pi over 8, sine of 5 pi over 24. Now, when you look at this problem, you might say, what in the world is this? How can we find the exact value of that? Well, if you look at the formulas of sum and the difference identities, you will notice that this looks like cosine of quantity alpha minus beta equals cosine of alpha cosine of beta plus sine alpha and sine beta. Now this expression over here represents the right side. So what is alpha? Alpha is 7 pi over 8. What is beta? 5 pi over 24. So you know that this will be same thing as cosine of 7 pi over 8 minus 5 pi over 24. What is that when you simplify? Now, as long as these two are both inside the parentheses, you could simplify it. So using the common denominator, this will be 21 pi over 8, oh, I'm sorry, over 24, minus 5 pi over 24. So you get cosine of 16 pi over 24. Of course, you could reduce this. You get cosine of 2 pi over 3. Okay, what is 2 pi over 3 in degree? I like to work with degree. So that's going to be 120. So cosine of 120. Okay, so how are we going to find cosine of 120 degree? Well, let's look at the, let me go over here. 120 is over here. What's the reference angle? Reference angle is going to be 60. And what is cosine of 60? Cosine of 60, you know that cosine of 60 is 1/2. But this is the second quadrant. And cosine in second quadrant will be negative. So as a result, you're going to get negative 1/2. Okay, so this whole thing is equal to negative 1/2. Okay, they want us to simplify this expression right here. Again, if you look at the formula, that looks like tangent of alpha minus beta equals tangent alpha minus tangent beta all over 1 plus tangent alpha and tangent beta. Okay? So this means that alpha is 6x and beta is 7x. Okay, look at the location. Here's alpha, that's 6x. There's a beta, and there's 7x. Okay? Notice the location of alpha and beta. So now, this is going to be the same thing as tangent of quantity 6x minus 7x, which is going to be tangent of negative x. Now remember even and odd functions? Do you remember whether tangent was even or odd? Well, tangent is odd because tangent of negative theta is negative tangent theta. Okay, this is a good time for you to review even and odd functions. And so this will be same thing as negative tangent of x. And notice we can go further because x is unknown. And all we have to do was simplify. So that is your final answer right here. So in this example, we have to rewrite this expression as algebraic expression. Now, if you notice, this part right here becomes alpha, and that part right here becomes beta. Now, do you remember what arcsine and cosine and arctangent represented? They all represent some angle. So, for example, for arcsine 2x, that means sine of alpha is 2x. For arc cosine x, that means cosine of some angle, let's call it beta. Cosine of beta is x. So let's draw a triangle here. Okay, you have alpha, and that's a right angle. So sine of alpha is 2x, and sine is y over r. I could rewrite 2x as 2x over 1, so y becomes 2x, and r is 1. Okay, now what about over here? Cosine of beta is x. That's beta, and that's right angle. I could rewrite x as x over 1. And cosine is x over r. So this is x, and r is 1. Now, what is the length of this right here then? Using Pythagorean theorem, okay, that becomes radical 1 minus 4x squared. Okay, again, you want to try this yourself. Using Pythagorean theorem, this part right here becomes radical 1 minus 4x squared. What about over here? What is that right here? Again, using the Pythagorean theorem, you will get radical 1 minus x squared. Okay, you might wonder why we need this information. You'll find out later. So you know that sine alpha is 2x. Now let's look at this. What is going to be cosine alpha? Cosine alpha is x over r. So it's going to be just radical 1 minus 4x squared. Okay, you won't need these two information later on. What about cosine of, sine of beta? What's going to be sine of beta? Sine of beta is y over r, so it's going to be radical 1 minus x squared. Okay? Again, you might need these two information later on. So now let's go back to this. What is cosine of alpha plus beta? We're looking at our formula. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Okay? Now notice we already have this information. What is cosine alpha? Cosine alpha is radical 1 minus 4x squared. What is cosine of beta? It's right here. It's x. What is sine alpha? Sine alpha is 2x. And what is sine beta? Sine beta is radical 1 minus x squared. Okay? Let's clean this up. So you're going to get x radical 1 minus 4x squared minus 2x radical 1 minus x squared. So this right here, we changed the original expression to algebraic expression. Let's take a look at last example. We want to rewrite that as algebraic expression. So again, this represents alpha, and that represents beta. So it looks like we're working with sine of quantity alpha minus beta in this case. So this means tangent of alpha. Let's draw a triangle. This is alpha, that's a right angle. Tangent of alpha is x. You could write it as x over 1. And you know that tangent is y over x, so this is y, and that's going to be your x. Okay, so tangent of alpha is x over 1, so that will be x, and this is 1. Now, what is your r? Your r is going to be, again, using Pythagorean theorem, you're going to get x squared, radical x squared plus 1. Okay? So what is sine alpha in this case? Sine alpha will be x over radical x squared plus 1. And what is cosine of alpha? Well, that's going to be 1 over radical x squared plus 1. Now let's work on beta. So this means cosine of beta. Cosine of beta is 1 over 2. So let's draw a triangle. There's a beta. There's a right angle. Now cosine is x over r. So what is this y value then? Well, using Pythagorean theorem, that's going to be radical 3. So we have cosine beta. What is sine of beta? Sine of beta. That's going to be radical 3 over 2, y over r. Okay, so whenever you use alpha, you have to look at this triangle. Whenever you use beta, you have to look at that triangle right here. Now, why do we need all this information? Sine alpha, sine beta, and cosine beta? Because when we work with sine of quantity alpha minus beta, what is the formula for that? That is sine alpha cosine beta minus cosine alpha sine beta. That's why we needed this information to evaluate sine of quantity alpha minus beta. What is sine alpha? It's right here. That's x over radical x squared plus 1 times cosine beta, which was 1/2, minus, what's cosine alpha? That's 1 over radical x squared plus 1, sine beta, radical 3 over 2. So when you simplify this, you'll get x minus radical 3 all over 2 radical x squared plus 1. Now, I mean, this is your final answer, but in the book, they might have simplified. I mean, the book does not like radical on the bottom, so they might have multiplied the top and bottom by radical x squared plus 1, and you should know how to figure that out. So this was my last example for sum and difference identities part 1, and we'll work on more problems part 2 next time.